Hello, everyone. I'm Eugene, a product training specialist at Garmin. Have you ever wondered why smartwatches flash a green light when measuring heart rate instead of a red light, but then switch to red light for pulse ox instead of green? Why use green light to measure heart rate instead of red light? First of all, it's due to the difference in penetration. Red light has stronger penetration, while green light is weaker. The advantage of green light is it can be partially absorbed by hemoglobin in superficial veins. The remaining unabsorbed green light is easily reflected back and detected by the watch's sensor. This makes it ideal for continuous heart rate tracking during exercise. As for red light, because of its high penetration, very little of it reflects back for the sensor to analyze. It's less effective for tracking heart rate during movement. Don't get me wrong, though. Red light can still be used to measure heart rate. We've all seen those fingerclip machines in hospitals. Those devices use red and infrared light to penetrate the skin and finger tissue, which is then received by a sensor on the other side. It measures heart rate and blood oxygen simultaneously. But as mentioned, because red and infrared light penetrate so deeply, reflection is minimal. This means the analyzable data is relatively limited and very sensitive. Sneezing, scratching, or even slight hand tremors can make data analysis difficult. Therefore, it's not suitable for a clip-on device while running or cycling. The red light on the watch is the same. It's not ideal for heart rate detection during exercise. So, how does this green heart rate light actually measure our heart rate? When the watch is placed against your skin, it emits green light into the veins. Part of the light is absorbed by the passing hemoglobin. The unabsorbed light reflects back and is detected by the watch sensor. With every heartbeat, contraction, and relaxation, the density of hemoglobin in your vessels changes. When hemoglobin density is high, less green light is detected. Conversely, when density is low, more green light is detected. The watch uses these density changes to determine your heart rate. So, to get the best heart rate readings, what should you keep in mind? To ensure reliable heart rate data, the watch must be worn securely. It shouldn't slide around on your skin. When you first put it on, the watch takes a few seconds to assess factors that might affect the measurement, such as arm hair, sweat, moisture, or even dirt. Once calibrated, it can provide reliable heart rate data. If the watch slides constantly during exercise, ambient light will interfere with the sensor. This makes it impossible to get accurate readings. How do you wear it correctly? While moving your arms during exercise, you shouldn't feel the watch sliding or rubbing. That's the right fit. If you feel even a slight slide, tighten it by 1 notch. Just ensure it's not uncomfortably tight. Don't over-tighten to the point where veins bulge, where your fingers turn purple. Also, some people have a prominent wrist bone near the outside of the joint. Keep the watch away from that bone, about 1 centimeter away. Don't let the watch sit directly on the bone, as it allows ambient light to interfere with the sensor. Speaking of reliable heart rate, some may notice inaccuracies during cold winter runs. The heart rate might seem a bit off. This is because the watch is worn near your extremities. Low temperatures cause vasoconstriction, making it harder for the watch to detect hemoglobin. Personally, when I run in the cold, I apply a warm compress to my wrist first, then put on the watch for the run. The heart rate readings are much more accurate that way. Since vasoconstriction lowers heart rate readings, if I tie my arm tightly, will the watch fail to detect a heart rate? During a basic life support course, I practiced applying a tourniquet to myself. Tourniquets are meant to stop major bleeding, so they must be applied very, very tightly. Tight enough to compress vessels and stop blood flow. My classmates were all groaning in pain because it was incredibly tight, sometimes even pinching the skin. But stopping blood loss is a matter of life and death, so the pain isn't the priority. Stopping the bleed is. Anyway, after I applied the tourniquet and the instructor approved it, I checked my heart rate on the watch. It dropped from 61 BPM to below 39 BPM. But not to zero. That's because I wasn't actually bleeding out, and the blood is still contained within my arm. As mentioned, the heart rate sensor measures the density of the blood. Even with reduced flow, hemoglobin still absorbs some green light. The remaining reflection is still detected. That's why even with a tourniquet, the watch still detects a lower heart rate. However, if it were at the fingertips, or if I were actually losing blood, detection would be much harder, or even impossible. Since this sensor is so effective, can I use it on my pets? Many vertebrates like cats, dogs, and primates also have hemoglobin to carry oxygen to tissues. So if you're interested, you could try measuring your pet's heart rate too. As mentioned, hemoglobin absorbs green light, but so does tattoo ink. If your watch is worn over a tattoo, you might see only 2 dashes on the screen, failing to measure heart rate entirely. In that case, you might need to wear elsewhere, or use a heart rate chest strap instead. We mentioned that red and infrared lights aren't typically used for heart rate. So why must pulse ox use red and infrared? Aren't they both measuring blood? Well, actually, the goal of pulse ox is to determine oxygen levels, not just track density changes in superficial veins. The penetration depth must reach the arteries containing oxygenated hemoglobin. This task is actually more difficult than measuring heart rate. So pulse ox uses red light, an invisible infrared light, not green light. They have stronger penetration to reach deeper arteries, to measure oxygenated hemoglobin and deoxygenated hemoglobin. How do red and infrared lights determine the blood's oxygen level? When hemoglobin carries enough oxygen, it absorbs more infrared light than red light. Conversely, deoxygenated hemoglobin absorbs more red light than infrared. Using these natural properties, the watch detects the oxygenation of hemoglobin. It calculates the percentage of oxygenated hemoglobin. This is your oxygen saturation, also known as SpO2. As mentioned earlier, red and infrared light penetrate deeply, so the data is limited and precious. Whether using a watch or a hospital finger clip device, you must remain still for successful reading. According to the Mayo Clinic, under normal resting conditions at sea level, an ideal SpO2 is between 95% and 100%. Anything below 90% is considered low. However, this still depends on your altitude, current activity, and personal health status. Pulse ox is a powerful feature, but let's look at some potential limitations. First is excessive movement, which makes detection difficult, as mentioned before. Next is poor peripheral perfusion, such as vasoconstriction, cold fingers, shock, or poor circulation. These individuals may often find they can't get a reading or get unstable values. If you frequently get unusual readings, consider consulting a doctor to check your overall health. Third is hyperoxia or hyperoxemia. In nitrox diving, divers breathe gas with higher oxygen than air. For example, a tank marked EN 32 means it contains 32% oxygen, compared to the 21% in standard air. In this state, the reading will always max out at 100%. So if someone is on pure oxygen, their reading will always be 100%. The fourth limitation is carbon monoxide poisoning. It reduces hemoglobin's oxygen-carrying capacity, preventing accurate SpO2 detection. Now that we've seen how watches use light, next time we'll discuss measuring heart rate via electricity, the principles behind it, and its pros and cons. Garmin Technology Series. See you next time.